Alright guys, Miss Metcalf here. This week we are actually starting our very last unit in 8th grade math, and that unit is preparing you for Algebra 1. It's called Foundations of Algebra 1. So the things that we're going to be talking about this week, next week, and pretty much until school is officially over, when it was supposed to be in June, we're going to be talking about things that you really want to pay attention to, because these are things that are going to be for sure a big part of what you're going to be doing next year in math as a freshman in high school. So these are things that you're going to definitely see again and be using a lot. And so if there's anything in here that you still are not quite comfortable with or understanding, you're going to want to make sure that you let your teacher know. So this week's topic, and specifically one of the topics we're talking about, is finding slope and y-intercept from a table. So hopefully you're thinking slope, y-intercept kind of sounds familiar. I know what a table in math looks like. And hopefully you're thinking linear relationships. Okay, so linear relationships, think about that word line that's in linear. So it's things that make a straight line graph. Okay, and so we're going to be talking about those linear relationships and specifically finding the slope of one and the y-intercept. Okay, so today we're going to look at tables, at least in this video. So what are those linear relationships again, just to remind you? So they have a constant rate of change, meaning, with every hour that goes by, it's always increasing by 5 degrees outside, which we know that's not really, our temperature would not be a good true example. That doesn't happen normally, but a constant rate of change, a better example might be something, every 2 shirts you get is $20, so when you go ahead and add on more and more, you end up having that 20 over and over and over again. So that's that constant rate, that amount that's changing repeatedly. The constant rate of change is what causes the graph to form that straight line. If it's not consistent, like how the temperature today, I'm sure, is not changing by the same amount of degrees every hour, it wouldn't make a straight line. It would be going up, down, a flat line. Maybe it stays the same for a few hours. It would not make a straight line. And so these things do have a constant change that's occurring in the situation. And linear relationships can have positive, negative, none, or undefined constant rates of change or slope. And I'm going to refer back to that more when we look at it on a graph. On this one, we're just looking at tables. But it can be a positive number, negative number. That's really all you'll see when we're doing tables. Now, linear relationships have a specific point that we can identify on a graph, which would also, in a situation, kind of be like the beginning of the situation, and we call that the y-intercept. On a graph, it's literally where the line crosses the y-axis, and you'll see that again when we're focusing on graphs. We use the slope of the linear relationship, that constant rate of change. We use that number and the beginning, or the y-intercept, to kind of name or describe our situation and be able to identify that linear relationship. That's how us math people kind of tell people, oh, here, this is how much I'm making each month, or whatever it might be. And you can write it as that equation. So what does that all really mean in Inglés, por favor? That's kind of supposed to be funny because that's Spanish. Anyways, let's look at an example situation. So Stacy and her friends go to a carnival. Okay, each ride at the carnival is $1.50, and it costs $5 to get into the carnival. So what would the y-intercept be? And remember, I just reminded you, or tried to remind you, about the fact that that's like the beginning of the situation. So literally think about it. When you arrive, the beginning of your time at the carnival, when you and your friends arrive there, what's the first thing you have to do? Well, you have to pay that $5, right? Because you get to those gates. Think about when you go to the carnival, the rodeo, you get to this part where they're like, hey, I need to see your pass, or I need to see some money, right? And so you have to give up that $5. So that's the first thing you do. So that's our y-intercept. That's the first thing you pay for. Now the slope, what would that constant rate of change be? Well, think back. The only other thing we know in the situation is it's $1.50 each ride. And if you think about it, well, yeah, that makes sense. It's a constant change because however many rides every ride that I go on, it increases by $1.50 with how much I'm going to spend. My total at the carnival increases. Okay, so that's that 150. All right, so that would be kind of the situation and putting it back in context for you. So let's look at our situation in a table, because that's what we're really going to focus on today, is looking at tables of values or ordered pairs and being able to identify the slope and the y-intercept. So I went ahead and took the information we had and I put it in a table. So obviously our independent thing, I can control how many rides I go on, right? If you're like me and don't like carnival rides because they're kind of like shaky and make you more nervous than normal ones, and I don't know, they just don't seem safe to me, you'll be at the zero at the beginning like me. You'll go with your friends, hang out, hold everybody's crap while they're in line, and then be on your way, right? And I'll spend $5. Whereas my friend who wants to go on rides over and over might spend $12.50 by the time she's done. Okay, so this is a table of that, and so obviously our independent, the thing we can control is that number of rides, the X, and what's dependent, what changes because of our X, is that total cost, right? That's what's going to change in this situation. That's the only thing that changes is my cost of my trip. Okay, so how can we do it on a table? If all we're thinking about here, and I know we know the answer, but we're pretending we don't, how do we find that change? Well, we look at each variable and we see how it's changing from one row to the next. So notice on your x's now, we see that it's increasing by 1 each time, right? 0 plus 1 is 1, so on. And it says we have to do that on each variable, right? So we know the number of rides is increasing by 1. And as that happens, the cost of your trip to the carnival increases by $1.50, right? That 1.5. Okay. And when we want to write that answer, and I put rate in all caps because rate, if you think back to unit rate or 6th grade, it's a comparison. And that's what we're doing. We're comparing cost and the number of rides that somebody went on, right? That's what our table has there. So how would we represent that? Would we say one ride per $6.50? Well, that doesn't really make sense. But if we said, one ride, or $6.50, excuse me, for going on one ride, that makes a little bit more sense, right? That $1.50 are dependent compared to our independent. So that's our change in y over the change in x. So we would have our, let's see if I can get back on here, $1.50 over the 1, right? So our change in y values, that 1.5 over the change in the x, the 1. And that means the slope is 1.5. In other words, it's $1.50 per ride. That's the change that's happening, okay? So what about that y-intercept in the table? Okay, again, we're pretending we didn't know anything. How could we look at the table and figure out the y-intercept? Okay, well, think about what the variables represent and think out the situation. Again, pretend we didn't have that context at all, because sometimes we just give y'all tables and you don't really know what it's about. So you can, I tell my students all the time, make up a situation in your head so that it helps, it makes sense. Okay, so if I go on one ride, it's going to be $6.50. If I go on two, it's going to be this much. So obviously, the more rides I go on, the more the cost is going to be. Okay, so that's what I see here. Okay, so that's what happens. Now, we're talking about the y-intercept. We're trying to figure out where does it begin. That's that beginning thing. So if I think about it, well, the beginning would be 0, right? If I don't go on any rides, then I'm going to pay $5. Okay, that's that point in the table right there, just got highlighted, that tells me, sorry, my dog is choking apparently behind me. June, stop. And so that is the point that is our y-intercept. It's the beginning. It's getting to the carnival, right? Even if you don't go on any rides, that's why it's 0 for rides, you're going to pay $5. Okay, so 5 is that y-intercept. Whenever x is 0, whatever that y value is, that number is our y-intercept. All right, let's go to practice problem number 1. I need to speed up before I run out of time. So here we have minutes and calories burned. Okay, we want to figure out our slope. It's that change in y values over the change in x. So slope change. Think about slope as in like a mountain top, or the ski slopes. If any of you have skied, which I haven't, but if you've been lucky enough to do that, when we talk about the ski slope, that's the incline, how it's changing, how the speed of your downhill journey is going to change, right? Think about it like that. So it's that change that's occurring. So if I look at my minutes, it's increasing by 1 minute each time. If you look at your calories burned, it's going up by 4.3. Obviously, I'm doing this for you, but you'd want to do some subtraction there and figure out what it's increasing by. Okay, now sometimes it will decrease, remember, but this time everything's increasing. So our slope then would be that calories, the 4.3 calories per minute, right? It's not 1 minute per 4.3 calories. That's not the way that would work. It kind of just makes more sense that each minute that goes by, so that each, that goes at the end. That's what per. Remember, when we divide, we figure out that each amount. Okay. Now, what about the y-intercept? What would the beginning of the situation be? So think about it again, make it up. It's minutes and it's calories burned. Okay, so I'm on the elliptical, right? I'm working out. So what would the beginning of my workout situation be? Well, it would just be me standing there, right? I'm not even starting yet. So in other words, nothing has happened. 0 time has gone by. Okay, so that y-intercept would be 0, because if no exercise has been done, no calories will be burned. Okay, so really we could put a 0 here and then another 0 here, and notice it would follow the pattern, because this is going up by 1. If you think about it this way, it's going down by 1. If I subtract 1 from 1, I get 0. This is going to go backwards this way. We're subtracting 4.3. If I subtract 4.3 from that, I would get 0. So my y-intercept would be 0. Alright, so let's look at practice problem number 2. Hours babysitting and money earned is what we're comparing here. So first we want to look at our slope, the change. What is the change that's occurring? Well, obviously, yes, there's a change in our money compared to the amount of hours that's going by, right? So look at our hours. That's increasing by 2 each time. And our money earned is increasing by 20. So for every 2 hours, I'm earning 20 bucks. Well, really, we can simplify that, right? Instead of $20 for every 2 hours, we like to get that unit rate if we can, that $10 per the 1 hour. 1 hour meaning that unit rate. Rate, again, constant rate of change. They all go together. Now, what about the y-intercept? Again, think about the beginning of the situation. In other words, I'm not babysitting. When I don't babysit, how much money do I make? Nothing, right? Okay, if I don't do any babysitting, I make no money. Again, you could think about now, really, it wouldn't be subtracting 2 here, because that would take me to -1. But you could think about in between here would be a 2, and in between here would be 20, right? And then you could do some pattern. But really, you could just think it out in this problem situation. All right, number 3. Notice there's no descriptors, just X and Y. Okay, so what do you do when it's like that? Well, you could make something up, or you just do the same thing. We're trying to figure out the change that's happening in them. Okay, a linear relationship, we know that it has that change, the slope, that's making that line increase or decrease. So let's see, on the X I have +2 each time, it looks like. On the Y, oh, notice it's going down. It's getting more negative. Be careful with that. Okay, so when I compare that, it's always our change in Y, that -2. It's going down by 2 on each Y value, over our change in X, +2. So that gives us a -1 for the slope. So that would be like maybe I'm losing $1 each day or something like that. Okay. Now, what would the y-intercept be? Well, we've been thinking about the beginning. And in this table, some kids say, well, it begins with -2. So that means -5 is the y-intercept. But really, when we say beginning, beginning is at 0. When I begin my bank account, I'm at 0 until I put money in there, right? So really, we're looking at that 0 for x, -7 for y. So the y-intercept would be -7. Okay, when we see x is 0, whatever value y is when x is 0, that is our y-intercept, that